This video is a review of scientific notation, which should obviously be a review. I'm hoping that this is not the first time you're seeing scientific notation, but again, you may not have used this over the summer, so it is a good thing to review. You will use scientific notation in chemistry. We'll use it to express numbers that are crazy small, like we might be talking about the mass of an atom. It's ridiculously small. Or we might be counting something that's really large, like how many atoms are in this beaker. It's crazy large. So scientific notation is a way of expressing those numbers that makes them a little bit more manageable. Let's say you have a large number. Let's say we have a number like, I don't know, 7,860,000. Something like that. We have some crazy large number. If I want to put this in scientific notation, I can put a decimal spot in the end if there is not one already. I put my decimal spot in the end. And then you might remember this. If the number is large, you should have a positive exponent of 10. So we're going to move the decimal spot either to the right or to the left until we get one non-zero number in front of the decimal spot. So in this case, I need to move the decimal spot to the left. So I'm going to take my decimal, and again, if there wasn't one already, you can add one. And I'm going to move it 1, 2, 3, 4, 5, 6. Insert my decimal. I want one non-zero number in front. You can, for now, drop the zeros at the end. And so I could report this as 7.86 times 10. And again, this was a large number, so we should have a positive exponent of 10, which is just the number of decimal spaces you moved. 1, 2, 3, 4, 5, 6. 10 to the positive 6. Done. Does this ring a bell? I'm hoping the answer is yes. And you're like, oh, this is so easy. I totally remember this. On the flip side, let's say you have a number that's given in scientific notation. I don't know, maybe it's something like 2.061 times 10 to the negative 4th or something like that. Okay, so I have a number in scientific notation. What if I want to take it out of scientific notation and write it in long form, we call it? Okay, so again, I'm going to be moving the decimal spot, and I just have to recognize that if I have a negative exponent, this is supposed to be a small number. So how do I make this a small number? I'm going to move the decimal spot in the opposite direction. So I'm going to take my decimal, it's already in there, and move it 1, 2, 3, 4. This is supposed to be a small number. Then all of these other spaces just get filled with zeros. So my final answer would be 0.002061. Okay. Again, I'm hoping that this is something that you've done in the past. Maybe not in the recent past. I don't know if you do this over the summer. It's kind of weird if you do. But I'm hoping this rings a bell because you're going to see it quite a bit. So again, if you have a positive exponent and you want to take that out of scientific notation, like this one on top, I need to make the number large. So to make the number large, I'd be moving the decimal 1, 2, 3, 4, 5, 6 places to the right. That should be a large number. If you have a negative exponent, we should be moving that number till we get a small number, or moving that decimal spot till we get a small number. Now, one more thing that I want to mention. When you're working with scientific notation in your calculator, you're probably going to see numbers that look like this. You might see something that looks like 2.061 e negative 4. And sometimes people will write that as their answer, like they're taking a test or a quiz and they'll write that on their answer. key and say, well, that's what my calculator said. Well, get back here. That's what it said on my calculator. It's got to be right. Oh, you'll probably lose a half point. That's calculator language. And again, in science, that number is supposed to mean something. That E, that means times 10 to the what? And then after the E, the -4, that's the exponent. So if you had this on your calculator, you would want to write this as your final answer on a test or quiz. If you leave that E in there, you will lose half a point. That again, that's calculator language. That's not proper scientific notation. If you wanted to enter scientific notation into your calculator, let's say you're doing a calculation and you want to multiply this by something, you have a button on your calculator that is specifically meant to be used for scientific notation. It's a little EE button, and if you're using like a TI-80 something, it's probably going to be a second function, and you'll see a little button that looks like EE. You could put this in your calculator as 2.06. Then you hit this EE key. And that means times 10 to the what? And then after, you just enter the exponent. We'll see, 6,1. And then I just say EE -4. Done. That EE key is for scientific notation specifically. That means 6.0 or 2.061 times 10 to the -4. This button means times 10. And you only have to enter the exponent. If you're a caret person, you can do this as 2.061 times 10 caret -4. You can do that. Just a fair warning that if you want to continue doing calculations, you'll probably need to put this in parentheses. Otherwise, your calculator won't do order of operations correctly. So as we get into calculations, especially with this scientific notation, just kind of practice a few with your calculator so you know that you're entering it correctly. Either of those two are totally fine. Personally, I prefer the EE key for scientific notation, but if you're a caret freak, you can do times 10 caret -4, but you'll probably want to put that in parentheses. Now again, there are some sample problems that will ask you to put numbers in scientific notation or take them out of scientific notation. So I would pause the video at this point, try a few, bring me back. If you get the right answers, great. Then you really don't need to spend a ton of time reviewing scientific notation. If you find that you are not getting them correct, then that's a red flag to come and see me for help. Alright, so here are the answers to some practice problems. Notice whenever I have a positive exponent, the number is large. Whenever I have a negative exponent, the number is small. A couple questions that people will sometimes ask. Obviously, if you have something like, oh gosh, 3 or 5 or 2, and you're moving the decimal spot until you get one non-zero number out in front, yes, you can drop these zeros. They're called leading zeros. We'll talk about them in the near future, but you do not need to put those in your final answer. Kind of the same thing, like, in 4 or 6, you're moving the decimal spot until you get one non-zero number out in front. If there's a bunch of zeros at the end of the number, for now, if you dropped those, that's fine. If you put them all in, that would be fine too. We'll kind of deal with zeros again in the very near future. So just double check and see if you have things reasonable. And again, if this is something that you are seeing for the first time, maybe come and let me know if you have any questions or concerns.